Hi. I don't know how to use Discord.
What?
You know how to use Discord?
No.
New attendant.
And I want to mess you up. You up.
And I work.
You up. You up.
Oh. So. So.
Yo.
You know how to work Discord?
Which one? A Discord?
Yeah.
Well, all you gotta do is just go to sign up for it.
I'm signed in for it. I just don't know how to use Discord. That's what I'm trying to figure out. Because I downloaded it and I added myself to the group, and then for some reason it just disappeared off my group. So, yeah.
So which group are you trying to get into?
Remember I told you I signed into it last night after I
you told me about it.
Yeah.
So there should be a button on the left. I think it's in the top left of the app if you're doing the mobile app. The way you change your groups is you press this button. This has a list of all your groups. Press the one with the bumblebee.
That's what I'm saying. It's saying that I'm not even in that group anymore.
Well, click on the invite that I sent you, because that invitation link doesn't go away. It should be good forever. Hi, friend.
Okay, let's see if it stays. Okay, it's there now. We'll see what happens when I swipe up.
I mean, you should be able to sign out and everything, and it shouldn't take you off of the server unless you exit the server.
I posted that picture in there because I needed help on it, but yeah. And I did chapter 18 too, and I have questions about that too. Even though I did the work, still says, you know how I always get messed up with math. So yeah, just know I did the work and it's correct. And I'll send you when I take the second test. I'll send you the stuff for it.
All right. We can talk about that, yeah, afterward. So first order of business, yeah. Just to make sure that I have a solid record of when and who you has been in my class at the beginning and near the end of all of our class meetings. Just say something in chat. No expletives, but it could be as simple as here, or it could even be a hey, what's up, yo, whatever. Just so that I have a log, because the program does not record the participants, but it does record the chat log. So this way I'll have timestamped everything. So if there's a dispute, I can go back and check it out. So that's how we're doing the attendance. Let's see.
So you said whenever we joined the live, just say something?
Yeah, whenever you log in, just type something.
Type something, got you.
Yeah, on the group chat, not the I mean, I want you to talk in the audio chat too, but not for the attendance deal. So, okay. Well, please remember that the tests are up on WebAssign and close Friday. So go ahead and take care of that.
It's still partial credit for sending it to you, right?
Yeah, if you send me an email with the work, and it has to be within, a couple minutes of finishing the test, so that you didn't just do it. If the answers don't match up, then I'll definitely be like, what? So, yeah, so if you send me the work that you did for that test, you can get some partial credit back on some of the test questions. All right, that is optional, but I would suggest it. So, okay, go ahead and start up here. So we're talking about waves, and we said that they follow the same pattern as a sine graph, which is why we call them sine waves. All right. And we started talking about two of the qualities of these waves that we could tell. We found the height of the wave was one of the qualities. So the distance from, we define it as the distance from the 0 line, not the distance top to bottom. So does anybody know what the height of a wave is generally called?
The peak, right?
The peak.
The peak, like P-E-A-K, or like
No, the highest point is a peak, and the lowest point is generally called a trough. But the height could technically be anywhere. So you could say the height at this point, or the height at this point. So it starts with an A.
Is it like aptitude?
That's close. So it is amplitude. So this is kind of a measure of how, we'll say how strong.
Altitude.
No, not altitude. It's amplitude. So the height of the wave is in anywhere you ask about, it's always the amplitude at that point. But the max height we'll often say A. Can also sometimes be the referred to as the total amplitude of that sine wave. Even though the amplitude does change, up and down. Sometimes people will just refer to the maximum height as the amplitude. Okay. We also had the length of a wave. And what did we say about the length of a wave? Something a little bit different about it. So it's not just from here all the way to the end, because realistically, this wave actually keeps going on forever in both directions. What we said was the length.
Wave height or the sea level? Wait, which one are we on?
So the height is the amplitude. So you can have the maximum amplitude, which is the distance from the zero line to the peak. But the amplitude really is like just the height at any point. So the amplitude is maximum, and then it gets smaller, and then it becomes negative, and then it gets smaller back to zero, and then it repeats the cycle. So that's the whole idea behind waves, is it's a cyclic motion. This thing moves in a cycle. And the length of the wave is the length of one cycle. So the easiest way to measure this is usually peak to peak. And the letter we use for it is usually this one, which is lambda. And this one doesn't have a fancy terminology. So the length of a wave is literally called wavelength. So far, these are the two qualities of a wave that we have. Is how far does the wave travel before it gets back to its peak amplitude? Okay. And there's another quality of any, this is true of any harmonic oscillator, anything that goes, that oscillates around a certain point, something that we had for springs and pendulums, and it was how fast they oscillate. So there's two ways of talking about how fast this thing goes back and forth. You can either talk about how long it takes to do one cycle, or so how many cycles per second? So, and these two things are just related to each other. So if you have one of them, you can very easily find the other one. But does anybody remember from back in the day? We were talking about springs or pendulums. What one of these two things was called? Either the time it takes for a spring to, drop down and come back up.
You talking about potential and
It's not potential. Potential has to do with energy. So this has to do with a time.
A rotation?
So you could say, if you're talking about something spinning around, you could say
A cycle? No.
the time that it takes to complete one rotation also has this name. Or you could say how many cycles per second, how many times it will go around in 1 second is another way of talking about it. So maybe how many cycles per second, you might also say, is how often does it
Revolutions?
cycle? What?
Revolutions?
No, that's how many times it goes around. But I want how many times it goes around per second. How many revolutions per second?
That wouldn't be frequency or a period of time, would it? Let's see.
Yes. So
Say yes.
period.
Haha, look at God.
why are you sitting in your car still?
How you know that?
Because you sound like you sit in your car.
Oh, I'm just sitting here smacking on this food.
So just like the name, I won't ask for specific examples, but when you hear the word period, there is something that often comes to mind. And that's because it happens. One period takes about a month. And this is another word that's associated with the thing that this gets associated with. So the period is how much time it takes to complete one full cycle.
Dang.
How many cycles per second is another way of saying how frequently does this thing happen.
Once every month.
Yeah, 1 per month.
Mm-hmm.
So frequency and period exactly are related like that. We'll say frequency is 1 over the period. Okay. Another way you could think about it, if you are, I'll say, adventurous enough, is the wavelength is how long the wave goes in space before it repeats. And the period is how long it goes in time before it repeats. So they are very similarly related, but not directly. One is in time, one of them is in space. So these are the qualities that we're going to use to talk about waves. So let's see what we can gather from this information. Now, I'm specifically going to be talking about wavelength and frequency or period. So we're not really going to care about amplitude for right now, but these are the two things that we're going to use. So say we had a wave traveling through, and at time equals 0, this is what it looks like. If you were able to take a snapshot of it, it looks like this. And at 5 seconds later, the wave might look like this. What can we figure out about this wave, given this this information? We'll call this X. Actually,
The start of the wavelength is at a different point.
okay. So,
And it has a wider
all right, so the wider thing, you're probably right. But pretend for a second that I could draw both of these and they were the same sizes. So your first point that you made is exactly what I wanted to bring up. So remember, technically these waves go on forever, but how far did it move?
What's the count on the line?
So let's say each of these is 1 meter.
Can you finish the black line automatically starts at 0. So it's 0, so it's 0, 0, then 2, 0.
Yeah, so it moved from 0, 0 to 2, 0. Okay?
Okay.
Very good. And in 5 seconds. Okay?
Mm-hmm.
So, what can you tell me about it?
For every 5 seconds, it moves 2.
Okay, so for every 5 seconds, it moves 2 meters. What is a different way to package that information together?
I'm frozen. I don't know.
You said for every 5 seconds it moves 2 meters?
Yeah.
Okay. I'm
Is
just getting
Is that the same wave, or did you make like 2 of the same wave?
It's supposed to be the same wave 5 seconds later. So it's moving.
Uh-oh.
So
So basically, you just shifted it over 2 meters.
yeah, well, it's moving, right?
Yeah.
So 1 second or at the initial time, it's right here, and then a couple seconds later, it's right there. But the whole wave moves, right? So, but don't give up on me. Don't say for every 5 seconds it moves 2 meters.
Okay.
Flip those numbers around.
For every 2
2
meters, 5 seconds passes.
Right. I was just saying, so for every 2
So
meters.
you might also say that it is traveling
2 meters every 5 seconds.
Right.
And what thing is that? Meters
Per second.
2 meters per 5 seconds.
Yeah. It's a time distance interval, right?
Velocity?
A velocity. There you
Oh
go.
God. Distance over time. I'm tripping.
So the velocity is 2/5, or I mean, if you put that into decimal, it's 0.4 meters per second.
Yeah.
So what we can do here, if we know how far it moves, and we know how long it took to move that far, we can tell. I mean, that's how we define velocity kind of in the first place, is if we know how much it was displaced, we know how long it took to displace that much, then we know its velocity. Okay? Let's take this same idea.
For this chapter, we don't have to measure the wavelength, measure the crest, and then
So for this, we're not really going to have much homework in this chapter, or really any homework. This is setting you up so that you understand how light works.
Whoa.
We're just reviewing waves and the qualities of it. And I mean, this is actually the last day I think that we're going to talk about waves, because we've gotten to I think the point that we need to start talking about light as a wave. So same idea. I'm going to try and okay. So this is our wave at the start. And remember, it goes on and on forever. This is our wave in the future. So I hope we can see that. So let's figure out the velocity of this thing. What is the equation for velocity that we kind of just wrote on the board a second ago? Or we'll call it speed for right now. What is speed? What are the units of speed?
you talking about like seconds. Hold on, I got you.
What were the units of the velocity that we had a second ago?
seconds and meters.
We'll just stick with V for now. Seconds and meters. So seconds and meters.
Over seconds over Meters over seconds.
Meters per second.
Yeah.
Okay. Meter is a measure of what?
Distance.
Distance
Distance.
over time.
Seconds, yep, time. Okay. So, how far did the wave move?
What's the count? There isn't one.
Don't need it for this.
Half?
Half of what?
Half for the original or none?
So the first one starts right here. And the one in the future starts right here.
So would that be considered a period? Like
That would be a wavelength. Because whether you're measuring it from peak to peak, or this point to this point. This is how we define a wavelength. Is if you start at any point on the wave and you go forward or backwards a wavelength, you're at the same point in the wave. So if you start at a peak and you move forward a wavelength, you end at a peak. If you started at a trough, you would end at a trough. If you start at this point, you would end at this point.
We don't have a change in delta like in this.
I just told you the answer to.
No, I'm saying in general, are we gonna ever have one?
You might have things written on here, but the point is I already gave you what you would look for.
Gotcha.
Lambda. So it moves that far. And how long did it take to move that far?
T?
T. Exactly. So this is what I mean by the two, the physical wavelength and the time wavelength or period are connected. If a wave moves half a wave in space, then it also moves half a wave in time. So this is one of the qualities of a wave, is that the distance that it travels divided by the time that it takes to travel that far is always the same for that wave. And it's always that thing's wavelength divided by its period. Or what's another way we can write this using frequency? So how do you take T out and replace it with frequency?
So it would be the lambda over F?
No, because what does frequency equal?
1 over T.
1 over T. So what does T equal?
T times F? Well, T over F? Well, F over T. One of those two. F over T. T over F. I mean, T... F over 1. I'm here. I'm trying.
1 over F.
Yeah.
So plug that in here. You get lambda over 1 over F. But how does that simplify?
Lambda F.
Lambda F.
And you better, Dakota.
Oh man.
So this is the wave's velocity. And this is the important part, because this is, some people may have heard people talk about the frequency of light, or sometimes the wavelength of light. Those are the two ways that we define differences in light waves, which is what we will be talking about very soon. The idea is that the speed of the wave is equal to the wave's length times the wave's frequency. So I guess we can dip our foot into it. All right. Yeah, so we'll just continue on with this on Friday. The idea is that light is a wave. So yeah, this is brought up in very end of chapter 1. I'm sorry, chapter 21. Point, I think it's 7. No. So 21.11. This is where we're going to kind of jump in with light next time. But that's all we've got for today. So yeah, you guys make sure you do that test, and we will reconvene same time on Friday. All right. And if you got any questions, text me in the Discord channel. So y'all have a fabulous evening, and see y'all later.